Hello, hello. How's everyone doing? Just one second. Make Yash your co-host. Cool. Kubernetes. Should have probably started this like starting of the week or Saturday or something, but chalo koi nahi. Uh, Happy Eid in advance. I think it's tomorrow, right? You click my startup. Where was that? Phishing link. I mean, I'm smart enough to not log into a phishing link. More Notion Docs, Notion Docs. Hi, hello, hi, hello. Uh, you should start from the beginning. You should join Discord if you've just joined the cohort. Super 30 will announce soon enough. We're filtering there like a lot of applications. So we're in the process of filtering them. Microservice-based projects which uses Kafka, Redis, gRPC, rate limiting, and sidecar pattern. Interesting. Very cool. Almost everything here minus gRPC will be used in a Bolt-like application. You need sidecars. You may use Redis, you might not use Redis, or Kafka. You can use them basically. You can use one of them if you want to over-engineer. Use both of them. Use Kafka for notifications. Maybe Redis for where was Redis used in Bolt? I'm forgetting. I don't think I've used. Oh no, I have used it somewhere. I totally forgot where. But yeah, Bolt, just look at my Bolt video on YouTube, the second one, a mobile application. I think I've used everything minus Kafka and gRPC there. And you can introduce Kafka for, simple notifications, which is like the most common use case of Kafka. Anything else before we start? Today is an interesting class, probably a hard class. I'll try to take it very slow. Kubernetes is where I've seen a lot of drop off in both Super 30 and in the cohort as well. So we'll keep it slow, slowly try to build up the concepts. There aren't too many. Learning Kubernetes to be able to use it is not that hard. Depending on how deep you are going, as we reach GitOps, that it might get a little complicated. If you're building your own CRDs, it's a little complicated. There's something called the operator pattern that's a little hard. These are things that sometimes you don't even touch 1 year after joining the company. For the first 1 year, let's say, or 6 months, sorry, in your interview. Let me start recording actually. Second, that's the screen. Audio is correct. Yeah, what I was saying was the first part of Kubernetes to say, which means you can deploy your applications on it in a production level on a cloud in a cloud native fashion. So if you want to move from AWS to GCP, it's very easy. That part is not too difficult, but again, it probably depends on your current level. That's why it's probably very hard for people to follow along. So with that team, I did Kubernetes 3 times, and even after the third time when a DevOps opportunity came, I would say most, if not all of, not everyone, but like a decent chunk, still had no idea. Were ऊपर ऊपर से ही पता था. And it's very hard for them to digest. Even though it was an on-site class, 3 times it was taught in various ways. Probably I'll do the same in the cohort. I have Canva slides also. I have Notion docs also. So we'll probably go through both of them. It'll take some iterations basically to be able to understand Kubernetes. So let's see based on the poll where we reach. And if it's very hard, then we'll see if we have to do more recorded videos or if we have to go through a different way to learn, a more visual way to learn. But with that, how do I? What the hell? Screen share. There we go. Cool. Let's get into it. Kick things off. Oh, before that, the slides. Posting them in the chat. These are the slides for today. What is Kubernetes? Very high level overview. Nothing complicated until we reach slide number 3, where the architecture will get a little complicated. So slide 1 and slide 2 are very simple. We have done these things. Let's quickly recap them. One big call out: Docker is a prerequisite before you proceed any further. Kubernetes, you'll drop off very quickly in the 4th or the 5th slide if you don't know Docker right now. Kubernetes, popularly known as K8s, is a container orchestration engine, which, as the name suggests, lets you create, delete, and update containers. Is it close to ECS that we learned about? The answer is yes. It's very close to ECS. It's more It provides more tools to the developer. It is cloud native. It is not dependent on AWS, but it is very close to what ECS does. ECS stands for Elastic Container Service. Kubernetes is a container orchestration engine, very close to what things both of them do, which is they start a bunch of containers on machines. They let you visit those containers. They let you scale up the containers, scale down the containers without you having to log into a virtual machine. That's the high level need of a container orchestration engine. What is container? A Docker container, or there are actually many runtimes to create a container. That is what container over here means. Orchestration means starting and stopping containers. What is an orchestra? An orchestra is a bunch of musicians and there is one guy doing like this. So that guy is called the orchestrator. In this case, Kubernetes is the orchestrator, which means Kubernetes is the thing that is starting, stopping, repairing, updating containers. An engine is just, it's a container orchestration engine. This is useful when you have Docker images in the Docker registry, let's say, and you want to deploy them in a cloud native fashion. We have had Docker images until now, and we have deployed them on virtual machines. We have deployed them on ECS. If you want to deploy them in a cloud native fashion, which means you can easily move from AWS to GCP to DigitalOcean to Vultr to a fifth cloud provider, Kubernetes is great. What does cloud native mean? Okay, all clouds support a lot of Kubernetes APIs. Any cloud that you are on, you can deploy over there. If you want to move from one to another, very easy to do that. You want to not worry about patching crashes. You want the system to auto heal. This is something ECS also provided. This is something auto scaling groups also provided. Okay, if the server ever crashed, it would restart the server. It would always make sure if the 3 is the desired capacity, 3 servers will be up. ECS would always make sure if there are 5 containers that you want running, 5 containers are up. Very similar here. If any container crashes, Kubernetes makes sure it brings it back up. It auto heals the cluster of yours. You want to auto scale using very simple constructs. That means if you want to increase the number of machines in your fleet, or you want to increase the number of containers that you are running. Lastly, you want to observe your whole system in a simple dashboard. This is probably the least important use case here, but Kubernetes does give you a very simple dashboard through which you can observe your system, see what all containers are running, where are they running, so on and so forth. At a very high level, and this is not completely true, but at a very high level, this is how a Kubernetes cluster looks like. So this is the first jargon we are learning today. Kubernetes cluster. When you are starting a virtual machine, you are starting one machine. When you are starting an auto scaling group, you are starting 5 machines or 10 machines. When you use ECS, you don't even know kaun si machine chal rahi hai. You just tell AWS to start containers in a serverless fashion. You can use EC2 as well, but most of the times when you use ECS, you use Fargate, which means let AWS decide where the thing is deployed. When you use Kubernetes, you actually start a bunch of machines, let's say 5 machines. All 5 of these machines are running the Kubernetes ka code, whatever the github.com/kubernetes/k8s contains. That code is running on all 3 of these machines, all 5 of these machines. They all have each other's address. They can all discover themselves. All of these machines are what are called a Kubernetes cluster. What is a Kubernetes cluster? More than one machine, or even one machine, that is fine. But generally 3, 5, 10, 20,000 machines. In case of OpenAI, their cluster has 1,000 machines. In case of a smaller startup, it might be 20 machines. So this whole fleet of servers that all sort of can talk to each other, sort of know about each other, understand there are 20 machines, is called a Kubernetes cluster. And when you deploy your final backend applications, front-end applications, they might deploy in a fashion that looks like this. Okay, AWS machine 3 is running the front-end container 1. AWS machine 2 is running the backend container 2. First AWS machine is running the backend container 1 and backend container 3, which means let's say you have 3 backend containers because you're expecting a lot of backend traffic, but just one front-end container. They'll sort of look like this. It could be anything. Backend container could be here, could be here. It depends on Kubernetes, how it's deciding where to put which machine, where to put which container, which is based on some logic. If this machine is empty or doesn't have very high CPU usage, it'll put the next container over here. If this container dies and this container dies, this machine is automatically empty. So it'll move some containers from here to here. All of that logic is handled by Kubernetes. So you don't, as the application developer, have to SSH into a machine, clone a repository, install Node.js and run it. You just have to tell Kubernetes, कि यार ये बैकएंड कंटेनर 3 चला दो, ये फ्रंट एंड कंटेनर 1 चला दो, ये रहा मेरे डॉकर हब में. माय डॉकर हब हैज अ बैकएंड कंटेनर 1 and a front end container 1, whatever you want to call it, to do application backend, to do application front end, and Kubernetes takes care of deploying them. It depends on Kubernetes which node it wants to decide to deploy it on. Harkirat, how do I visit it? अगर फ्रंट एंड एप्लीकेशन यहां चल रही है, if the front end application is running over here, do I have to get the IP address of this machine and reach it? Of course not, right? That would be really bad, because if the front end container Kubernetes decides to move it from here to here, then the IP needs to change. If it decides to move it from here to here, IP needs to change. So of course, when you expose your application, it's not that ad hoc. There are constructs, APIs that Kubernetes provides you to expose your front end on something like whatever, frontend.100xdev.com. And irrespective of which machine you're running it in, you'll be able to discover the service. So this is what Kubernetes at a very high level looks like. We'll dive deeper into the architecture very soon. Kubernetes is also called K-TES. Why? Because it is K followed by 8 dashes and then S. Very common jargon for it. That's what Kubernetes is. This is very high level. Slowly, we'll dive deeper into it. Before Kubernetes, how are we deploying? Very simple. Backends we deployed like this. We put a load balancer in front of a bunch of machines, or we had a single machine where we had deployed the backend. It was running Nginx, Certbot, the Node.js application. It was exposed on a port. We were visiting api.website.com. If there was a load balancer, we would first reach the load balancer, and then our load would get balanced amongst these backend services. If we are not using a load balancer, then we would directly reach the machine. That's how we had deployed backend. Front end can be done in a very similar fashion. It can be done like this. It can be done like this, which means directly on a virtual machine. But this is true for Next.js frontends. For React frontends, for static websites, if you remember from our initial videos, the third or the fourth video of the DevOps cohort, this is how we exposed our front-end applications that were static. React applications that we had built into HTML, CSS, and JavaScript. Or if you are generally writing HTML, CSS, and JavaScript code, you use an object store like S3. You expose your front end in front of a CDN or a content delivery network like Cloudflare. If this feels jarring, we have covered it. Go back a few videos. This is not needed today. I was just showing, if you don't have the concept of Docker, if you don't have the concept of Kubernetes, how would you deploy your code on a virtual machine, which was how it was done up until 2013, 2014. This was the only way to deploy. There were some other tools, but mostly people would deploy like this. They would start a machine, start nodeindex.js here, start a machine, start nodeindex.js here, maybe put a load balancer in front, and that's what the domain name would point to. This changes significantly if you are using ECS or if you're using Kubernetes. So after Kubernetes, how does it change is what we need to understand. This will probably be the first slide jahan thoda dimag kharab hoga. Until now, I have just shown how backends were deployed before Kubernetes, hopefully very simple. Now, we're trying to understand how backends are deployed or frontends are deployed inside Kubernetes. And the reason I say this is very hard is because we have not written any code. We have not deployed any application yet. हम पहले architecture समझ रहे हैं. We are trying to understand the architecture first. So it gets a little jarring because कुछ किया नहीं अभी तक. We haven't done anything, and we are starting to learn the architecture of Kubernetes, which is why this slide might be a little jarring. Slowly, I'll try to explain. There are some components, very high level architecture of Kubernetes. So after your front end and your front, ignore the statement for now. Ignore what are pods. Let's just look at the architecture. Very similar to the architecture in the first slide. The architecture says that you start a Kubernetes cluster. तुम पहले 4 machines start कर दोगे where Kubernetes is running. Harkirat, how do I start it? Very simple. We'll start it locally very soon. We can start it on DigitalOcean. We can start it on AWS. Very easy to start a Kubernetes cluster. Give it the number of machines that you want, let's say 3, and then it has 3 machines that are running Kubernetes. By the end, your backends and frontends will be deployed like this. And notice there is a very small difference between AWS machine 4 and AWS machine 1, 2, and 3. AWS machine 4 is what's called the master node. What is this called? The master node. And AWS machine 1, 2, and 3 are what are called the worker nodes. So let me write down all the jargon that we're learning today. Number 1, we learned about cluster. Number 2, we're learning about master nodes versus worker nodes. Kubernetes expects that whenever you are starting a Kubernetes cluster, right, you need to have one or many master nodes and one or many worker nodes. In the worst case, if you don't have money, you only have one machine. That one machine can behave as a master and a worker as well. But generally, you have one master node, many worker nodes. Is it obvious what the master and a worker node would do? The master node is responsible for a lot of things. One of the things being the developer talks to the master node. The developer tells the master node, okay, please start 3 backend containers that are present on dockerhub.com/harkirath/backend. Please start one frontend container that is present on dockerhub.com/harkirath/frontend. I tell this to the master node. Master node doesn't run it here. It finds कि अच्छा, what are the machines that are currently not empty, but the least used, let's say. And it schedules कि अच्छा यार front end pod 1 यहाँ चला देते हैं और front end container मान लो अभी के लिए. Assume container for now. Let's start the front end container over here. Let's start the backend container 1 over here, backend container 2 over here, backend container 3 over here. Because the developer told the machine, okay, we need 3 replicas of the backend container. We want 3 containers of backend because we're expecting a lot of backend traffic. We aren't expecting a bunch of front end traffic. So just one container, one replica of the front end. The master's job is to not start the thing immediately here. It schedules starting these containers, these pods on various worker nodes. That means the master node is aware that this worker node is up, this worker node is up, this worker node is up. I can schedule the 3 things here. If this machine ever goes down, then again the master node realizes that अच्छा, this specific machine is down, so I need to move this front end pod from here to here. That also the master node does. So what is the responsibility of the master node? There are many, and we'll dive into the architecture soon. But the biggest responsibility is take commands from a developer, take declarative commands / desired state commands from the developer. We'll come to what declarative commands mean, and schedule the jobs on various worker machines. यहाँ पे ये चले, यहाँ पे ये चले, यहाँ पे ये चले. What is the benefit? Wait, as the developer, you don't care. You just tell the master कि यार ये कर दियो. Start 3 backend containers. The master starts it. It's responsible for deciding which machine is the most apt for running a specific job. Now comes a lot of jargon and slightly heavy jargon. So slowly, let's try to understand it. The first jargon is nodes, which is the simplest jargon for today. In Kubernetes, you can create and connect various machines together, all of which are running Kubernetes. Every machine is known as a node. So this machine, and this machine, we have a 4-node cluster. All machines together are called a cluster. So I can say I have my Kubernetes cluster running in Civo, or I have my Kubernetes, which means I have 4 nodes total running. One of them is the master node, and 3 of them are the worker nodes. There are 2 types of nodes in Kubernetes. Master node. Unfortunately, today there's nothing I can do because ऐसा नहीं है कि मैं router को यहाँ pull कर सकता हूँ. So let's try for 5 more minutes, and if it's still really bad, then we'll see how to proceed. To repeat what I was saying the first jargon for today is nodes. A node is nothing but all 4 machines of yours. Together, they're called the cluster. So this is a Kubernetes cluster which has 4 nodes or 4 machines. There are 2 types of nodes. The master node, or what is called the control plane. The node that takes care of deploying the containers, healing them, listening to the developer to understand what to deploy. The developer might tell you after 10 minutes, okay, please decrease the backend container count to 1. So it's this guy's job to schedule removing this from here, removing this from here. The backend developer at 8 a.m. morning might say, now start 10 containers. So then you have to start 10 containers everywhere. Or the master node will schedule the 10 containers everywhere. So the master node is the node that takes care of deploying the containers, healing them, listening to the developer and understanding what needs to be done. Master node is nothing but a machine that's running a bunch of servers, a bunch of databases. So what does it look like under the hood? अंदर चल क्या रहा है? The master node has many parts. Four important ones here are API server, etcd or etcd, kube scheduler, and kube controller manager. Maybe one more that I have missed over here is kube cloud control manager. There are 5 important processes that are running on a master node. जो एक master node है, ये Kubernetes की processes है. These aren't user-defined backend containers or front-end containers. This is some Kubernetes processes that are running on the master node. Each one of them has some responsibility. So let's dive deeper into what is the API server's job. What is HD's job? What is the job of the kube scheduler? What is the job of the kube control manager? Let me look at Q&A just for a second to see what's up. Lagging. Still a lot of lag. Alrighty. I can try one thing, which is hotspot. Unsure if that will fix it, but worth trying. Give me a second. Mobile hotspot. It would fix a lot of things, but let's see. There we go. In here. Cool. We are back. In Q&A, can someone tell me, is the lag good? Is there still some lag? I don't think it's because of my CPU, what someone suggested. I think it's just my internet. Can you guys see me? Can you guys hear me? Are we good to go? Can I proceed? Q&A में someone let me know if you can see me, or let me open chat. Can you guys see me? All right, proceeding. Cool. So what I was saying was, okay, someone asked a question, Kirat, what if multiple backends are running? That means multiple database connections are there. Won't that cause a problem? We have discussed this yesterday. Connection pooling fixes that. So go to yesterday's class. वैसे there will only be 10 containers or 20 containers or 15 containers, which is something that a database can handle. Cool. मास्टर नोड का आर्किटेक्चर समझ रहे हैं गाइस? द आर्किटेक्चर ऑफ द मास्टर नोड, ये जो चारों में से एक मशीन है, इसके अंदर चल क्या रहा है? व्हाट ऑल प्रोसेसेस आर रनिंग बाय डिफॉल्ट ओवर हियर? व्हाट डू यू एक्सपेक्ट इज रनिंग? द डेवलपर is going to tell this AWS machine कि start 3 containers of dockerhub.com/harkirat/backend. How will the developer talk to the machine? Through an HTTP API, right? It could be gRPC, someone said. It could be something else. It could be WebSockets. It could be WebRTC, got it. But HTTP is the most common protocol. That is exactly what is running on this AWS machine 4. So what is the first component over here? API server. This API server is what a developer talks to. You basically send a request to https:// masternode.100xdevs.com/deployment/start, or /container/start. Let's say you are talking to this API server. You are telling it, yaar, please 3 processes start kar de. Please start 3 processes over here. When you say that, this gets stored in HT. So what is HT? Think of it like Postgres. It's just a key value store. It's like Redis. If you've ever used Redis for storing keys and values, HT is the same thing. It's the database that Kubernetes chose. Harkirat, why did it not choose Postgres or MongoDB? It's their choice. It's a lightweight key value pair, which is enough to store information in Kubernetes. And hence that's the database that they have used, or the key value store that they have used. So when you come over here, this is the developer. The developer talks to the API server, tells Kia, please start this container. This request gets stored somewhere here. Kia Harkirat wants to start a new container, a new pod, some Kubernetes construct of this specific Docker image on the internet. यहाँ पे वो store हो गया. Then comes the kube control manager and the kube scheduler. Let's get to the kube scheduler first, because the name is sort of giving it away. What would the kube scheduler do इसके बाद? The kube scheduler decides कि अच्छा ये Harkirat wants to start. I will decide where to start it. So the kube scheduler's job is to make sure that it has all the metrics of the three machines, and it can decide which of these three machines Harkirat's container one starts on, which of these machines Harkirat's container front end container starts on, back end container starts on. That's the kube scheduler. And then there is something called the kube control manager, which will be, it'll be more, you'll understand this better once you understand deployments, replica sets. But if you break this down, Kubernetes controller manager. So before that, we should understand what is a controller and what is a manager. Controller is a more generic term in computer science. If you've ever heard of control loops, which basically means an infinite loop that is constantly checking something. That is what a control loop is. The word controller comes from there. A very good example, which you'll see in the Kubernetes docs only, is a thermostat. If you have a thermostat in your house, or in Canada we have them, we don't have them here. You just set a temperature wahan pe, ki I want 25 degrees as my house temperature. So constantly the thermostat is checking okay, what is the current temperature. Acha, it is 28 right now. So it will start the AC so that it slowly approaches 25. If it goes down to 22, then the thermostat will stop the AC so that slowly the temperature goes up. So a thermostat is sort of a control loop. It is an infinite loop that is constantly checking कि Harkirat wants the temperature of the house to be 300 or whatever, 25 degrees Celsius. Agar abhi temperature is 28, then it will start the AC. And after another second, it will check what is the temperature, 27, it will start, keep the AC on. As it reaches 25, it will still have the AC on, it will go down to 24, the control loop or the thermostat will say, AC go off kar dete hain. AC is turned off, it will start to go up. So this infinitely running process is what's called a control loop or a controller. What is the kube controller manager? It basically means that Kubernetes has a bunch of these infinite loops running. It has a bunch of controllers running whose job is to do something. User has told, I want to start 3 backend containers, right? We put this process over here. Then there is an infinite loop running that is checking kaun si process abhi tak schedule nahi hui hai, which process hasn't been scheduled, or which pod currently needs to be scheduled. That is one controller that is constantly running and checking that and scheduling a job. There are other controllers. For example, node controller is a good one, responsible for noticing and responding when a node goes down. Kube controller manager starts a bunch of control loops or a bunch of controllers. One of them being the node controller, which is it will constantly check koi node down to nahi ho gaya. And if it is down, if let's say this specific node goes down, it will understand that backend pod 3 now needs to be moved over here or needs to be moved over here. It will reschedule backend pod 3. So the controller manager ka job is to start a lot of containers. Just one of those containers is the kube controller manager's job is to start a bunch of controllers. And one of those controllers is the node controller. We don't yet understand deployments and replica sets, which is why I'm not diving into these two controllers. But there are many controllers that run in Kubernetes, and you can write your own controllers as well. Eventually, when we learn about the operator pattern, we'll understand how can you write your own controllers. How can you tell the kube controller manager कि इनको भी run करो? These are my custom controllers. But long story short, what does the kube controller manager do? It starts a bunch of controllers and constantly runs them. It is the manager of all of these controllers. What are the controllers doing? They're constantly checking something. And the simplest example of this is the node controller, which is constantly checking, is this node up? Is this node up? Is this node up? And if any one of them goes down, then it will reschedule the pods to go from here to here. That's the architecture of the master node. 4 components. There are many more actually. There's another important one, as I said, which is Kube Cloud Controller Manager. Read about it, or when we reach load balancers, we'll read about it. But I'll be clear, 4 important ones. API server, which is the standard HTTP server that is running, that the developer can hit to check what all is running right now, check the state of the containers that are running, and also schedule new containers. Backend mein start kar do, front end mein start kar do. HD, which is the database. Whenever you start a container, it gets stored over here. Whenever it gets scheduled, uska status changes over here. Whenever it is running, uska status changes over here, so on and so forth. This is like a database for Kubernetes. It's not for Kubernetes. Like HD it's like Postgres. HD is a independent project that runs. Kubernetes chose to use it as their own database, but you can use it independently also. This has nothing to do with Kubernetes. If you have your standard full stack application, wahan pe also you can use HT as the database. Kube scheduler for scheduling and deciding where does a pod go, and controller manager for starting and running a bunch of controllers. What are controllers is something that will be clearer eventually, but effectively it's an infinite loop that we run. And eventually, when we reach the operator pattern, we'll write our own controllers. Tab that it'll be a little clearer. Okay, what is happening under the hood inside a controller? Cool. That is the master node. इसका आर्किटेक्चर समझ आया है, थोड़ा थोड़ा समझ आया है, थोड़ा थोड़ा नहीं समझ आया है, totally fine. You don't need to know this. When you're running this, you start a Kubernetes cluster, you start deploying apps there. So as a just a DevOps engineer who's deploying applications, doesn't matter if you don't understand the internals. It's good to know though. Eventually, it's good to explore these, go inside, and maybe read through HD and see ke andar chal kya raha hai. But even if you don't understand it, it's fine. It takes some digestion for Kubernetes to kick in. Okay? Master node architecture is done. What do you think is the worker node architecture? Yahan pe, other than the scheduled containers, other than whatever the developer told us to start, what else should be running over here? Yahan pe aur kya chal raha hoga? Can you think of some things? What are the standard processes that might be running here? We know the master node is scheduling jobs. There is a kube scheduler here that is deciding ki yaar container 1, please go over here. Backend container 2, please go over here. Backend container 3, please go over here. So is this guy sending an HTTP request here कि यार ये start कर दे, or is this guy polling the master node and checking is there a new job for me? Is there a new job for me? And the answer is this worker machine is checking on the master node कि मेरे लिए कोई नई job आई क्या? Is there something new you want me to run or schedule? So what should be one process running here? That one process should be checking here, am I supposed to start something new? And if the answer is yes, then that specific process should start that container on this machine. So the first process that runs on a worker node is something called the kubelet. The kubelet is talking to the master node ka API server, is understanding here what all jobs do I need to run? Is there some job that you want me to stop? Is there some job that you want me to start? So it's scheduling those jobs on the pod. It's running those jobs on the pod. It's letting the master node know that I have started to run it. It is crashing right now. It is running right now. All of those statuses, it is posting back to the API server on the master node. It is also asking the master node from time to time, कि यार कुछ नया आया? Should I schedule some new jobs? Should I stop some old jobs? So the kubelet talks to the API server on the master node, understands what jobs does it need to run. The kube proxy is responsible for eventually when we reach how to make these applications talk to the internet. This is responsible for networking. The name proxy gives it away. Okay, as your containers start, as your containers are starting, the proxy will give them some IP addresses, internal IP address, external IP addresses, and that's how nodes will be able to talk to each other. So what does the kube proxy do? The kube proxy, which is running on a worker node, is responsible for generating IP addresses, making you communicate between the pods or the containers that you are starting. The third thing is the container runtime. Name is giving it away, container runtime. This is where the container actually runs. That means the Docker container or a Podman container or a different container runtime that container. Kubernetes supports every container runtime that exists. That specific container actually running, it runs in the container runtime. So these are three worker node components. The kubelet, an agent that runs on each node in the cluster. It makes sure that the containers are running in a pod. It talks to the master node, understands what containers to start or stop. It starts or stops them. Kube proxy is a network proxy that runs on each node. It is responsible for you being able to talk to pods, or pods being able to talk to each other, or the external world also being able to talk to the pods. And lastly, the container runtime. In a Kubernetes worker node, the container runtime is the software responsible for eventually running the containers. It's very similar to the container runtime that you have on your machine when you're starting Docker containers. But Kubernetes has a bunch of layers on top of it, which we can dive into if need be. But there is something called container runtime interface and CRIO and a bunch of other, these are container runtimes. Docker is one, but CRIO Container D is another one. CRIO, I don't think this is a container runtime. Yeah, this is a container runtime. CRI is also something, Kubernetes Container Runtime Interface, which means whatever container runtime that you're eventually starting, you are supporting Docker, Container D, they should follow a specific interface or a format. We had interfaces in TypeScript. They were the same thing. They would show you the shape of an object. Similarly, the Kubernetes Container Runtime Interface is an interface that defines, how should container D CRIO or, Docker expose some APIs. One second, I'm receiving a call. Sorry about that. Cool. So to recap, there are two types of nodes in Kubernetes. There can be many master nodes, many worker nodes. Usually there is one master node and multiple worker nodes based on, how much traffic you're expecting, or more importantly, how much compute you need, 20 CPUs total, 50 GB RAM total, or, if it's lesser or more. Based on that, you can have multiple nodes. These are the two types in architecture. Master node has 4 components: API server, HT, kube scheduler manager. Kube controller manager. Also has another one called kube cloud controller manager. And worker nodes, 3 types, 3 components that it runs: kubelet to talk to the master node, kube proxy to expose the networking on the pods, and container runtime that actually runs the containers. ये second वाला jargon थोड़ा थोड़ा समझ आया. Nodes, I'm sure you understand. 2 types of nodes, I'm sure you understand. The internal components may not be clear, which is fine. The biggest thing you need to understand is the API server and how you talk to it, because this is something we will be exploring very soon. The master node API server is something we will send HTTP requests to very soon. तो इतना समझ आना चाहिए कि इसकी क्या job है, because as a developer, you are only interacting with the API server. When you are asking to schedule a new container, when you're asking the status of a container, you are talking to the API server. So the master node's API server is something you should definitely understand. And everything else, you may or may not want to understand, but you will need to eventually, when we reach, creating your own controllers or creating your own CRDs. At that point, you might have to dive into these. But other than that, the architecture isn't super important to digest, especially, the internal components. Do we understand nodes? Let's do a poll. Nodes, type of nodes, and the internal architecture of these 2 types of nodes. 83%. Good, not great, but proceedable, because as I said, internal components, I'm assuming, is where most people are confused. Let me finish the whole thing, and then I'm happy to do we'll take a pause and we'll see how to, before we proceed, because iske baad we'll start to write code. So we'll take a pause, do some Q&A after this. Let me finish the whole thing. Jargon for today are nodes, we understand. Cluster, just a bunch of nodes together is what's called a Kubernetes cluster. So this is a 4-node Kubernetes cluster that's running my applications. Images, we already know there's nothing new here. Docker image is a lightweight standalone executable software package that includes everything needed to run a piece of software, including the code, runtime, libraries. We have covered Docker in detail, Docker images in detail, so nothing new here. A good example is, this is the MongoDB image that you can now run inside your Kubernetes cluster as well. Containers, just Docker containers, nothing related to Kubernetes right now. A container is an image in execution. We have run Docker containers many times in our local machines, so we understand images and Docker hopefully very well. If you have done Docker, you understand images and containers. The new jargon today is pods. And agar ye samajh aa gaya, to aaj ki class sukhi hai, guys. If you understand this, then today's class should be smooth. It's a Kubernetes specific term. It's called pods. And what is a pod? A pod is the smallest and simplest unit in Kubernetes object model that you can create or deploy. Basically means that whenever you want to start a container, let's say a backend container or a front-end container, what you're starting is a pod. You are not starting a container. You can start a pod which has just the backend container. You can start a pod which has just the front-end container. Or you can start a pod that has both the front-end and the backend container. So a pod can run multiple containers inside. And that is the smallest unit that you deploy. उससे नीचे कुछ नहीं है. You can't tell Kubernetes to run Node.js code directly. No. Rust code directly. No. You can give it a container, but you can't give it a container either. You have to give it a pod. अब ऐसा हो सकता है कि your pod has a single container and that is fine. So it can be that this backend pod one has a single Docker container running. This has a single Docker container, single Docker container. And that is fine. That's how most of the times you'll be running applications. Every pod will be running a single container. But if you want, you can have a single pod run multiple containers as well, which is happening in this case. A single pod is running the backend and the front end container. What are the upsides and downsides? The biggest upside of doing this is that you can have very simple internal networking. The backend container can talk to the front end container on localhost. That becomes a little complicated when you have different pod for front end and backend. But if you want them to share, let's say, storage eventually, even though they can't really share storage very simply, containers can't share storage, right? If I start two Docker containers, they have their own file system. So this has its own file system, this has its own file system. But it's easy to make them share the file system somehow. Networking, they commonly share. So this guy and this guy, if this is running on localhost :3000, then this guy can access it by by hitting localhost :3000. Unfortunately, front end run on a browser. So वहां पे localhost :3000 won't make sense. But if this was a backend container 1 and this is a backend container 2, they can both find each other on localhost :3000. Or if this guy is running on 3000, then this guy can hit this guy on localhost :3000. If this guy is running on 3001, then यहाँ पे if I write axios.get 3001 or localhost :3001, I'll be able to identify this guy. So the reason for you to start two containers together in a pod might be that you want them to talk to each other very easily. But generally, every pod, when you deploy a pod, it's running just one container. You can run multiple containers, but generally 99% of the times, every pod that you're starting will be running a new container. So you can say that pods and containers are very close and very similar, but they're not. A pod can run multiple containers. It's a Kubernetes construct. It is different from container, which is a more of a Linux construct. A single pod can run multiple containers, but generally a single pod runs a single container. Cool. Do we understand this much? This was, I'm hoping, simple enough. इसके बाद तो simple चीजें करिए. And to recap everything, the jargon we're learning today now includes clusters, master nodes versus worker nodes, architecture of master and worker, declarative commands. ये मैं बताऊंगा क्या है. I mean, I'll share what this is, but React and Kubernetes are very similar in a way. They're both declarative. What does declarative mean? I'll come to very soon. And lastly, we understood about pods, which is the new thing. Images and containers, I'm sure you already knew. But pods is this new thing that we are learned. And today our job is to just start a few pods in our Kubernetes cluster. That is it. आज इससे ऊपर कुछ नहीं करना है. कुछ pods start करने हैं, which means I want to start some containers, but you can't really start a container. What you start is a pod जिसके अंदर एक container चल रहा होता है. So let's start creating a Kubernetes cluster locally for free. You don't need a cloud account today. You can run it locally for free. Of course, by next class, we should run it on AWS, DigitalOcean somewhere. But today, let's try to run Kubernetes locally on our machine. There are two ways. One is called Minikube, which was the common one for many years. And then there is Kind, which stands for Kubernetes inside Docker. If you have Docker, use Kind. If you don't have Docker, then I would just ask, why do you not have Docker? Because, just have it on your machine. Minikube will work, but it'll be a little hard for you to do multi-worker setup or multi-node setup in Minikube, which is why I would suggest just use Kind. You can do it on the cloud as well. If you already have, Vultr, DigitalOcean, AWS accounts, go to Kubernetes, start a new cluster, get the config from there. But abhi ke liye, today, I'm going to run it locally. I would urge you to run it locally as well. Step 1 is to install Kind or Kubernetes inside Docker. To take 2 minutes or maybe 5 minutes. I'll answer questions until then. Install 2 CLIs for me, please. One of them is Kind. And the other one is, in the next slide, it's called kubectl. Next. Slide 4 has the installation steps for Kind. Slide 6 has the installation steps for kubectl. Please install both of these in your machine. By the end, you should be able to run Kind on your machine. It should be available CLI to you. you should be able to run kubectl on your machine. It should be a available CLI. So please install kind and kubectl on your machines. Take 5 to 10 minutes. That is fine. But before we proceed, you need to do this. Naito, you'll be very lost. Meanwhile, I'll spend some time in Q&A. You can say that pod is a single unit of executable Docker compose. That is a beautiful way to put it, but it's more generic than that. It can run other container runtimes, but yes, that is beautiful. It's like you're running Docker compose, which means, single unit that's running 3 containers, 5 containers. That is beautiful. Good analogy. But localhost will point to the container itself. So how will 2 containers talks on localhost? Yeah. So that is the thing about running 2 containers in the same pod. They share the network. So if this is a pod, and this is container 1, and this is container 2 running on the pod, they are both sharing the network. This does not happen when you have a Mac machine where you run container 1 and container 2. यहाँ पे this guy's local host is this container का local host. This guy's local host is this container का local host. So it doesn't happen here. But pods में, if you're starting 2 containers or 5 containers in the same pod, they do share the network. They don't share the file system by default. You can make that happen. But they do share the network, which means when you write localhost, you mean this is pod ka local host, is pod ka IP, through which you can use reach either this guy or this guy based on the port. So yes, it doesn't happen on a Mac machine, but it does happen in a pod. In a pod, all containers are sharing the network. In a Mac machine, that does not happen. But localhost will point to the container. Okay, that is done. Why are pods required? Why can't we run containers directly? Yes, that is a beautiful question. And the answer is a single pod, as we have just talked about, can run multiple containers. If only containers were, let's say pods wasn't a concept, only containers were a concept, then what would have happened was these containers would have had their own network. There would have been no way for them to talk to each other than doing something complicated. Local host पे दोनों कभी बात नहीं कर पाते. Sometimes you want if one thing crashes, the whole thing crashes. Sometimes you want if this container goes down, the backend container goes down, front-end container also goes down. They're very closely related to each other. So in this case, what would happen is if container 2 goes down, Kubernetes will understand this pod is crashing right now. It will restart the pod. And then only when the pod will be up, container 1 will be available, container 2 will be available. So in case you need 2 containers to run together, basically atomically, which means if one of them stops, the other one should stop. If one of them starts, the other one should be started. If one of them stops, the whole pod should restart. Then it makes sense to do this, right? It's a it's very similar to Docker Compose, like someone said. You want multiple things to be running together atomically. If you want to scale up, you want to scale them up together. If you want to scale down, you want to scale them down together. That is why you might, that's one of the reasons pod exists as a concept. And container directly kuch nahi hota. I'll do a video on Mobile Magic locally. There's a lot of steps now. Why would a pod contain a single container generally? Yeah, great question. Basically, as someone said, read about it and you'll understand. But as we deploy applications, you'll just see this. By generally, I meant when you are writing 99% of your full stack applications, you will never make a pod run front end and back end together, have multiple containers running in a pod. बहुत specific cases में होता है. For example, in Mobile Magic, this happens. The Mobile Magic repo that I have, वहाँ पे it is the first time that I actually had to do this. I had to run multiple containers in the same pod. So if you go to Mobile Magic Ops app orchestrator manifest, you'll probably see a deployment. जिसका spec अगर तुम देखो, I have multiple containers here. I have the Kubernetes orchestrator. I have a single container here. But there is some app, not the front end, not the worker hoga, I think. Let's see. Deployment. Is this the worker? No, this is caddy. Could have. So where's it was worker containerized? I think it was. This though definitely isn't. There is some, you anyways don't understand deployment files, but long story short, यहाँ पे, wherever the worker deployment file exists, which I'm forgetting now, is it this? No. Somewhere here, there is one pod which has multiple containers, and this was the first time I had to do that. I had to start a pod which had multiple containers. If someone finds it, let me know. But wait, after let's say I've deployed 20 applications on Kubernetes, the first time it happened, I had to make two containers talk to each other really fast. Or I wanted to make sure if container one has started, then container two starts. So that is why I had to do that. My exam reason with that now, whenever you go to bolt.new, what is mobile magic? It's something like this, bolt.new. When you go over here and you ask it to make an application like a mobile app using Expo, there are a lot of things that are running on the server. There is VS Code running on a server. There is you chatting to VS Code. There is a Git backup or something that's backing up everything to GitHub. There's another process that's backing up everything to S3. So all of these processes sort of need to run in the same pod because they need to share the network for easy communication. And more than that, they need to share the storage, which also becomes a little easy if everyone's running in the pod. And lastly, it becomes really fast and it becomes atomic. So it's good. Even better example. Because reasons are बहुत सारे now. As I look at it practically, I'll try to explain it. It'll probably go above your head. But in case of mobile magic, this thing right here, whenever you're creating a React Native app, chess app. Let me share a practical example of when this happens. If I want to create a React application that's a chess application, and I'll get a UI like this. I have VS Code running somewhere on a pod. So in my pod, there is one container that is running VS Code. But then when the user says a follow-up prompt, if I say, make it dark mode and I press enter, I talk to an API server, which also I am running over here. It's not an API server. I think it's an API server. It's what I called the worker. Why did I do that? Because this worker will talk to ChatGPT and then GPT will tell here, create these files. And this worker will be able to forward it to VS Code slightly easier if they are both running together. If they were not running together, तो शायद ऐसा होता कि the worker went down. Then my application should go down completely. This user should see somewhere ki disconnected, and then the whole thing should start again. Then the user should see reconnected. So that is the reason to start these together. And then the other processes that I was talking about was an S3 backup or whatever backup thingy, which is taking the files जो VS Code में लिखी हैं, the file system that's over here that has my source code, and backing it up to S3 constantly. And then I was talking about the GitHub backupper, which is taking these files and pushing them to GitHub constantly. So they need to share storage, which is something you can do separately also. You don't need to make sure all containers are running in the same pod, but it becomes more, it's just more cleaner to have them run together. So that's another practical example of when you would need one pod run multiple containers. It's actually happening here in this application that we have written. But as I said, it happens rarely. When you hit a specific use case, storage needs to be shared or network needs to be shared. For example, here, the worker and VS Code sort of talk through WebSockets. So the worker has, actually there's a fifth service here, a WebSocket service that runs through which, the worker, whenever GPT tells to do something, it forwards it here, which forwards it to VS Code. So the architecture is a little complicated, but you get it, right? Multiple containers need to start together. If one of them crashes, that means the application cannot work anymore for that user. For this user, now the application cannot run anymore, which is why the whole pod should restart. And that happens if one of the containers stops. If they were independent, then one of the container would stop. But the other ones would still be up. So the user will see some problem. Okay, I'm able to send the request, but it doesn't show up on VS Code. So that is why you might want to merge everything together. And the way it happens in, whatever mobile magic is, every user gets their own pod. Whenever you come here and start a process, a new pod is created for you, which has so many containers running, and you are talking to it. A pod is very isolated. If there are 2 users currently on our application, there will be 2 pods running in our Kubernetes cluster. Each one of these pods has some resource limits. This pod can only use 1 CPU at max and 1 GB RAM. Something like this. So, this resource limit applies to the combined processes, 5 processes here, because we want to make sure the user that is coming here has limited resources on our server. They're not blowing up our server. So you can define them combined together here. But if they were separate processes, you would have given separate resource limits. If they were separate pods, you would have to give separate resource limits. If they're together, you can give combined resource limits. So that's another reason why you might want to merge multiple containers in a pod. All right. But usually we only use one container in a pod, so there is no need for shared network. So why even use it and not use a cluster directly. So yeah, मुझे question. But usually we only have one container in a pod, correct? So there is no need of sharing network. Yes, network isn't shared anyways. If there are multiple pods, there is no network sharing anyways that happens. And if you don't need, yeah, you don't get it either. So I don't really understand your question. What is the command to check it got installed or not? So make sure you have kind running locally and kubectl running locally. If both of these commands are running, then you are good to go. If either of these commands is not running for you right now, you will face problems. And of course, Docker should be running as well. So maybe 5 more minutes and then we'll start. I'll look at Q&A for 5 more minutes and then we will proceed. Is each pod like a mini machine? It's not a machine or a VM. Like theoretically, sure. Like in an abstract fashion, yes, it's like a virtual machine that is running. But because it's, yeah, as you said, each pod has their own network, has its own, doesn't have its own storage. Like containers have their own storage, but yes, you can think of it this way. Okay, I have started a small mini virtual machine, but it's not a virtual machine. It's much more lightweight than that. Virtual machine has, a lot of things. It's built on top of a hypervisor. It has strict 2 CPU, 4 GB RAM, something like that. This guy doesn't have anything strict. It has resource limits. कि यार 1 GB से ऊपर नहीं चलना चाहिए. But you could have a, Kubernetes worker node, which is 2 GB RAM and 4 CPU, which runs 5 pods inside. Each one of the pods has, let's say 1 GB limit. So that is the limit कि maximum कितना पहुंच सकता है. But each pod can, यहाँ पे ऐसा हो सकता है. What I'm telling you is कि why is a pod different from a virtual machine? That is your question, right? If these are 5 pods, then each pods might have individual limits. कि यार I can max use 1 GB RAM and 2 CPU. Each one of these pods has that. So you might think कि हरकिरत हम तो 2 ही pods start कर सकते हैं. We can only start 2 pods here because this node has 2 GB RAM, 4 CPUs. But that's not true. That is a limit. ऐसा हो सकता है कि this guy is only using 0.5 GB, this guy is only using 0.5 GB, this guy is only using 0.2 GB, this guy is only using 0.3 GB, this guy is only using 0.5 GB. So there is shared resources amongst all of these pods. So it's not really a VM because a VM has specified limits. This has resource limits. इससे ज़्यादा नहीं जाना चाहिए. Yeah, so pod is a virtual abstraction. It is just an abstraction, which means it's nothing. It's just it's not a physical thing. कुछ container कट गया, एक machine कट गई, या virtual machine has been started. No, it's just a abstract concept कि 4 container इस pod में run हो रहे हैं, ये 4 container इस pod में run हो रहे हैं. How to decide if we need more nodes or more pods? That's a beautiful question. How do we scale, Harkirat? How do we decide if we need more nodes or more pods? This is something we should discuss eventually, but since we have 2 minutes, let me do it. If this is your Kubernetes cluster, let's say currently you have two worker nodes and one master node. So let's ignore the master node for now. This is the master node that we will ignore. These are 2 worker nodes, and let's say both of them have 4 GB RAM, 2 CPUs. Okay. Your backend is going crazy. Everyone's hitting your application. So you started 1 container, you started 2 container or pods. This is backend pod 1, this is backend pod 2. Now, if I add more pods, is it helpful? अगर मेरी इस मशीन पे एक पॉड चल रहा है, इस मशीन पे एक पॉड चल रहा है, this pod has no resource limits attached to it, this pod has no resource limits attached to it, does it even make sense to scale up the number of pods? Does it make sense to do this? The answer is no, क्योंकि बात तो वही हो गई, requests will get load balanced amongst this pod and this pod, but overall both of them combined still have at max 4 GB RAM, 2 CPUs, right? So you can scale up the number of pods until you reach a point where the number of pods equal to the number of worker nodes. There is a nuance here, which is कि अगर आपने resource limits लगा रखी हैं कि at max you will use 1 GB RAM and 1 CPU, then of course you should scale up the number of pods as well. ये 2 होने चाहिए यहाँ पे, ये 2 होने चाहिए यहाँ पे, नहीं तो you're not using the full capacity because 1 CPU. Now the limit has been reached. Now if you scale up more, there is no benefit. क्योंकि combined these 3 can, even though they can use 3 CPUs, only 2 CPUs are available. So if this is the resource limit attached to every machine, or sorry, every pod, so at max, दो का ही sense बनाता है. If there is no resource limit attached, then just 2 pods are enough because those two, there is no point scaling up the pods. आप scale करोगे भी कोई फर्क नहीं पड़ेगा उससे, क्योंकि you'll have 10 pods running over here. But again, all of them are now sharing 4 GB RAM, 2 CPUs. If you have one, that one has full access to 4 GB RAM, 2 CPUs. That's how you scale up pods. Scaling up nodes is a whole different game. Okay, you know, the way that happens is through resource minimum requirements. Okay, this will at least use 0.5 GB RAM or whatever CPU, 0.5 GB CPU. So what happens is when you scale up a lot, let's say whatever 8 times, right? There are 4 CPU, there is 2 CPUs here. So if you say my number of pods are 9, तो 8 तो यहाँ fit हो जाएंगे, because this is the minimum CPU that you said the pod can take. तो 8 तो fit हो जाते हैं. As soon as you do 9, then ये auto scale हो जाता है. A new node comes up because the new container needs to go over there. So that's how node auto scaling happens. So basically 2 ways you auto scale. Either you scale up the node or you scale up the number of pods. Both happen in very different ways. There is a node autoscaler. There is a horizontal pod autoscaler. We'll come to them eventually. But the way it happens is you have resource limits and resource minimums on each one of these CPUs. And that's how Kubernetes understands, now I can't fit 9 containers in this much machines. So I'll start a new machine, and the new machine pay, the 9th container goes and you have more compute now. Cool. ठीक है. Let's do a poll. Does everyone have kind and kubectl running locally? Let's do a poll. And if you think you can't do it, then also select yes. अगर आपको लग रहा है कभी नहीं हो पाएगा आज आपसे, तो just select yes. Or if you're not doing it, basically. 83%. That's decent. So let's proceed, guys. जिनका नहीं हुआ है, do it after the class. Just focus on the class basically, and then after the class do it. Cool. Let's start our very first Kubernetes cluster locally. Do you do it? I don't do it, honestly. Whenever I'm testing, I test it on a cloud. I have a small DigitalOcean cluster running. I'll do all the testing over there. Rarely do I start it locally. It's good for initial testing purposes. So the way to start a Kubernetes cluster using Docker or using kind is there are 2 ways. You can either do it directly like this: kind create cluster and give a name to your cluster. Let's say local. So let's try that. Kind create cluster -- name local. In my case, there is already a cluster that exists with the name local. So let me delete it. Kind delete cluster name local. Let me restart it. And now, what does it say? Creating cluster local, ensuring this node image exists, and now it's starting it. Starting control plane. What is control plane? The master node. The problem with this is it'll start just one node. If I do a Docker PS, you will see a single node is running, which now has to behave both as the master and the worker. It's not like you can't do that. It's not like you can't have a single node which behaves both as the master and the worker. It's a bad idea. You shouldn't do it. So even though this works, and you can do whatever you want after this, you can run all the commands from here. Delete it. If you started it right now, delete the local cluster. And let's start a cluster which has 1 master node and 2 worker nodes. Okay? We understood in the last slide that there is a master node that you should have. There are multiple worker nodes you should have. When we are starting it locally, if we run this command, we start a single node that has to run both the things. And hence, let's do this. Let's create a cluster.yaml file that looks like this. Kind cluster API version, ignore what this is for now. Nodes, 3 nodes हमें start करने हैं. 1 master node and 2 worker nodes. If you create this clusters.yaml file, which I already have, so let me cat clusters.yaml. I think it looks the same, so it will work for me. If you create a local file called clusters.yaml and then start the Kubernetes cluster like this, kind create cluster -- config clusters.yaml -- name whatever you want to give your Kubernetes cluster, whatever name you want to give your Kubernetes cluster. So if I run this, is when it will do a multi-node setup. It will start 1 master node and 2 worker nodes, which is a good thing for us to have locally so we can debug eventually. अभी हम काफी चीजें debug करेंगे. We'll see where the application starts. Did it start on worker node 1 or worker node 2? So it's a good idea for you to run a 3-node setup than a single node setup. So what are the steps that I took? Number 1, I created a clusters.yaml file. Number 2, I started the cluster locally by running kind create cluster dash dash config and dash dash name. Now, if I do docker ps, I see 3 containers are running. One of them is the master node. 2 of these are worker nodes. You can do the same thing using Minikube. Not the same thing. Minikube doesn't start it inside Docker. Minikube was something even I used back in the day, like Goldman times, when I was running Kubernetes locally. But kind is, easy enough, works inside Docker. If you have Docker, it makes your life very easy. So I would use kind if you're running it locally right now. Okay. To recap, in this slide, we have started a Kubernetes cluster locally. How do I know the Kubernetes cluster is running? Number one, the command should have given you something. And number two, if you run Docker PS, you should see 3 containers running. One of them the master node, 2 of them worker nodes. Can we do a poll? Shall we proceed, guys? Can we move to the next section where we start talking to the Kubernetes API? Simple enough? All right. So in this section, let's talk to the Kubernetes cluster. Let's tell it, start a pod, stop a pod. So the master node exposes an API that a developer can use to start the pods. Do we remember this? The master node का आर्किटेक्चर अगर हम देखें तो it exposes an API that you can use to talk to the container. We have a master node running now. If I run Docker PS, I can see I have 1, 2, 3 nodes running. One says local control plane. One says local worker. One says local worker 2. So probably this is the master node that I have. Where is this master node running? As you can see, I have a port mapping here. Localhost colon 51563 points to 6443 inside the container, which means this is probably my API server URL. On my Mac machine, there is a port mapping from here to here inside the container. So hopefully, if I open this, I can talk to the Kubernetes API server. Now, the thing about the Kubernetes API server is you can only talk to it over HTTPS. When you are running it locally, you will see a certificate issue. There is no domain name over here. So just click on advanced, click on proceed to 127 and save. That is fine. And now you are hitting the API server. There is some HTTP server you can hit. Is it a to-do server? No. So you can't do /API/v1/to-do. You can't do /API/v1/sign-up. It is an HTTP server, very similar to the one we have written until now, but it has something else, right? It will have something like, API v1 start pod with container, whatever, Mongo, something like this. The URL will not be /API/v1/sign-up. It will be something else. There is some schema that the server has that we can now talk to this server and tell it to start things. So isn't it beautiful? You just need to talk to an HTTP server, tell it कि भाई इसको start कर दे please, and it will start the pod for you, versus you having to SSH into a machine, do so many ugly things. So we have the Kubernetes master node running. Master node is running an API server that is exposed to us. Now, we can hit that master node. And one of the URLs, for example, that you can hit is /API/v1/namespaces/default/pods. Now, what is namespaces? What is default? We will come to aage jaake when we reach namespaces. Don't worry about it. /pods. So hopefully, this should return me all the pods running in my Kubernetes cluster. What pods are running right now? Nothing. I just started the cluster. I did not schedule any pods. If I go over here, it should return me an empty array, right? कि कोई pods run नहीं कर रहे हैं. But if I see, it says pod is forbidden for user anonymous. It says कि यार header कहाँ है, cookie कहाँ है. You are trying to access this specific URL, but it's an authenticated URL, of course. You can't simply go to it in a browser and hope to see all the pods. Even though there is no pods running right now, there is no actual information in here. But there is a 403 status code that comes because मेरे credentials कहाँ हैं cluster के? I have not sent my credentials along here. So, how can I talk to the Kubernetes cluster with my credentials? Should I send a header over here, a query param over here? How can I talk to the HTTP endpoint and get all the pods? Of course, in the future, I will post pods as well. I will start pods as well. Abhi ke liye I'm trying to get all the pods that exist. The simple answer is kubectl. Your config, your secrets, credentials, auth key, JWT, cookie is automatically put in a file called .cube/config. When you did a kind start cluster or kind create cluster dash dash name local, the cluster that started, उसके जो credentials हैं were shoved by default or were shoved inside the dot cube slash config file. So try to see this file in your local machine. I'm not going to because it has my prod secrets as well. But if you try to do this, you will see, okay, some secrets have been put in there. The file looks something like this. Okay, for example, these are two clusters that I have. The local kind cluster, uske credentials, and my Walter cluster, AWS cluster, uske credentials. So if you cat this file, you'll see कि आपके Minikube के, sorry, not Minikube, your kind credentials are in here. So this file is the thing that you need to keep very safe. If you share it with a friend, that friend can sort of talk to your Kubernetes cluster. Of course, they need to be on your laptop because you're running it locally right now. But eventually, when you run it in production, tab bhi your credentials will be here. If you look at my cd.cube folder, I have so many files in here for all of my clusters. I just keep them together. My DigitalOcean worker, which is one Kubernetes cluster that I have, my AWS cluster that I have, a Civo cluster that I gave access to a guy called Pratyush. उसके सारे credentials मैं यहाँ डाल देता हूँ. So whenever I want to, connect to that cluster, I move this file to config. कहाँ गई config? This file, .cube/config. So this one. There are better ways to switch context between cluster 1, cluster 2, cluster 3, cluster 4. The way I do it is मैंने सारी files यहाँ डाल दी हैं. I put all of my cluster credentials over here. This is my Walter cluster. This is my AWS cluster. This is my DigitalOcean cluster. This is my Civo cluster. I just copy this to config, and then I start to talk to the, Civo cluster. If I copy this to the config file, I will start to talk to the AWS cluster. Question is how? How will I talk to it? मेरे credentials यहाँ आ गए. I know कि my .cube folder has a config file where my credentials are. How do I now talk to the Kubernetes cluster? And the answer is kubectl. This CLI that we just added, if you run kubectl get pods, so this same HTTP request will go out /API/v1/namespaces/default/pods. Same HTTP request goes out, but it picks the credentials from here. It sends some auth token along with the request. And hence the Kubernetes cluster responds back with no resources found in the default namespace. It is telling you कि अभी तो कोई pod start नहीं हुआ है. So is this CLI doing an HTTP request under the hood? The answer is yes. Does this CLI put something extra in this request when it's talking to it? The answer is yes. It picks your credentials from here. .cube/config में जो भी credentials हैं to your local cluster, picks it from there, sends it in the request. That is why it is able to hit the server and get a 200 status code. If you see over here, we don't get a 200 status code because I'm hitting the same URL, but I'm not sending my credentials along. One more thing that you can do is add verbosity to this specific command. What that does is, what does verbosity mean? I want to see all the logs with a very high verbosity level. मतलब बहुत verbose होने चाहिए logs, बहुत ज़्यादा चीजें print होती दिखनी मेरे को. तो you will see कि it is sending a request to the same URL /API/v1/namespaces/default/pods ? Limit = 500. So it's sending the same request, but it is also sending some auth header along with it, which is why this request responds back with something like this, which right now says there is no pods currently in this cluster, but eventually as we start more pods in this cluster, you'll see them over here. So do we understand how do you start the Kubernetes cluster? How do you do get requests over there? कौन से pods present हैं? Abhi we are only dealing with pods, so we are only asking for pods. Eventually we'll ask more things. One more thing you can do is kubectl get nodes. This will show you have 3 nodes currently in your Kubernetes cluster. Eventually we might have a 5 node setup. We might auto scale up and down. So whenever you think that your Kubernetes cluster is down, this is one of the first commands that you run to see has one of the node gone down or something else has happened. So are we good to go? Do we understand this? Let's do a poll. Cool, simple enough. All right. So next up is starting a pod. यही बची है चीज अभी तक. वी अंडरस्टैंड 5 jargons: clusters, nodes, images, containers and pods. These are just Kubernetes sort of constructs, or sometimes these two are Docker constructs. These two are very simple Kubernetes constructs. This is a new Kubernetes construct called pods. ये हमें समझना है अब. We have created a cluster of 3 nodes. How can we deploy a single container over there inside a pod? हमें एक pod start करना है जिसके अंदर हमें एक image start करनी है. So we can run something like this: docker run -p this nginx to start the container locally using Docker. But are we using Docker? No. What are we using? We are using Kubernetes today. So how do you run your very first pod using Kubernetes? Again, all you have to do is call an HTTP endpoint. But of course, it's very hard to figure out. How do I start the a pod with this image on inside my Kubernetes cluster? So the easy thing is to just use kubectl. Kubectl run the name of the image. इसको आप कुछ भी नाम दे सकते हो. nginx Harkirat, Harkirat, Harkirat 1 2 3. This is the name of the pod that you are starting. This is not the Docker Hub image name. This is the your name that you want to give to your pod. Could be backend, could be front end, something like that. This is the image that you want to eventually start, which is the Docker image basically. So this will eventually start this Docker image. hub.docker.com/_nginx. ये image मुझे अभी रन करनी है. If I want to run Mongo, then I will replace this with Mongo. If I want to run Postgres, I will replace this with Postgres. If I want to run my own machine or my own image, I'll replace this with 100x devs / whatever, mobile magic backend container, something like that. And what port this will eventually expose? This exposes nothing. Adding -- port equal to 80 literally does nothing. It's usually used only for documentation purposes. इसको करने से आपकी एप्लीकेशन एक्सपोज नहीं हो जाएगी. एक्सपोजिंग अ पॉड इज अ होल डिफरेंट बॉल गेम. वी विल कम टू इवेंचुअली. This is just starting the pod. It is not accessible at all anywhere. You can't access this pod. You can't hit the port 80 on the pod. So let's try running this. Kubectl run nginx. This is the image I want to start. This is the port I want to start it in. This is the name of the pod. Could be Harkirat, could be Raman, could be backend 1, could be backend 2, like that. It says pod nginx created. If I now do kubectl, so I have an alias for k on kubectl, so I can simply run k get pods, and I will see now I have one pod running in my Kubernetes cluster. Harkirat, where is it running? We have 3 worker nodes, right? Sorry, 2 worker nodes, local worker 2. इस पे चल रहा है या इस पे चल रहा है या फिर क्या पता कंट्रोल प्लेन पे चल रहा हो. ऑफ कोर्स इट इज नॉट रनिंग ऑन द मास्टर नोड. वी ऑलरेडी अंडरस्टूड दिस. इट विल रन ऑन आइदर वर्कर नोड 1 or worker node 2. So how do I know where it is running? For some of you, it might say container image pull or container starting, something like that, because I already had the image locally, which is why it started running immediately. For you, it might be picking up the image from nginx, which is why you might see a different status. What you can do is you can watch the command k get pods -w. That will constantly watch the this specific query, and if the status changes to running eventually, you'll see that status change over here. So what did I do abhi tak? 2 things I did. Sabse pehle I started the nginx pod by running this command. I can't start it again now. If I try to start it, it says pod nginx already exists. Second thing, I'm now doing kubectl get pods, and it's now showing me one pod is running. I can also do kubectl logs or the name of the pod, and as you can see, I can see the logs as well. Kubectl logs name of the pod, and I can see all the logs. So it is running for sure. I can't access it unfortunately, but my pod is running for sure. If I want, I can also tail the logs by running -f, which means follow. Now, as more and more requests come to this nginx server, abhi to there can't, because I can't really talk to this server, but you can see more and more logs over here. So I was able to start my very first container by running whatever kube run nginx -- image port 80. You can start more. Let me start another container. This time, let me call it Mongo container or Mongo pod, let's say. This is the name of my pod. And the image that I'm starting is the MongoDB image. That works as well. If I do docker ps now, sorry, if I do k get pods now, it says this container is creating, this container is running. So nginx वाला container चल रहा है. Mongo container is still in the process of running. Let me charge my machine over here. So what did I say? I said you can watch this command. So as the status of this changes, as it is able to pull the image from there to here, it will start running. One more thing you can do is you can describe the pod. Kubectl, describe pod nginx, and you will see a bunch of things about this pod. कि इसका name क्या है? Nginx. What is its namespace? Don't worry about. We'll come to it. What's its priority? Don't worry about. We'll come to it. Which account is running it? Don't worry about. We'll come to it. Which node is running it? Beautiful. We see कि ये pod exactly कौन से node पे चल रहा है. We had local worker. We had local worker 2. So the nginx pod seems to be running on the first worker. And if I do k describe pod mongo dash pod, then you will see this is running on local worker 2. So can we see some magic कि हाँ, it schedules things correctly. The first pod it's scheduled on worker 1. The second pod it's scheduled on worker 2. It has a bunch of more things. The other important thing is the events or the logs over here. Okay, slowly you can see what happened. It successfully assigned this to local worker 2. मतलब second machine पे चलना चाहिए pod. Started to pull the Mongo image, was successfully able to pull the Mongo image, started running this container, created the container and started running the container. So all the events that happen to start the pod, you can see over here by running the command kubectl describe pod and the name of the pod. So kubectl describe pod and the name of the pod will give you a bunch of details. Important ones are if you are interested to see, what is the node. Eventually, we'll understand what are labels. They become important. So annotations become important. IP is important, not important, doesn't really matter. A lot of this is abstracted from you when you eventually expose the pod. That is why I'm saying this is not really needed. And events are again, another important thing. Cool. ठीक है जी. So now I have two pods running. I can see the logs as well. K logs, Mongo, whatever, Mongo pod. I see it is running. As I said, you can't yet reach it. And there are ways to reach it. Eventually, we'll understand services. Kya hoti, how do you do that? Abhi ke liye, good questions to ask are, how can I stop a pod? Very simple. Docker, sorry, k get pods, k stop pod, stop hota hai. Delete, I think. K delete pod, Mongo pod. This will stop the Mongo pod or / delete the Mongo pod. And if you do k delete pod nginx, it will stop the nginx pod. Simple enough. Now, if I do k get pods, I have no pods running. Cool. So we understood how to start pods. We know pod starts multiple containers. We only started one right now. And we were also able to stop the pods. How many pods can I start? The answer is, as I said, infinitely many. Of course, there is some limit. If you start 20,000 pods, a lot of them will be stuck in an unknown stage or, a container creating stage. They won't actually be able to start because of resource limitations unless you have 1,000 machines. So, and also it doesn't make sense to start 20 if you only have 5 nodes. If you only have 5 nodes and you start 10, 20 pods, so, a lot of them are just sharing resources. Only 5 pods should have been good enough. How can I visit the pod? Where is it available? Can I go to localhost colon 80? Can I go to localhost colon 8080? Different question for, the next class. This requires another Kubernetes API object called services. We have only understood pods abhi tak. Pods only start containers. They don't expose them. Exposing them is done by something else. We will reach there eventually. We know how to stop the pods. We know how to get the status of the pods. My machine is lagging. I can totally see my image being really slow right now. Stop share. Just 1 second. It's very laggy. I don't know what I'm running that makes it so laggy. Just give me 1 second, guys. Let me stop a few things locally. Not that I'm running too many things. Quit and quit and quit. Item, zoom. Why is item taking 100%? Item. Quit terminal. Maybe quit Google Chrome as well. Is it better? Still very laggy. At least the video is laggy for some reason. Sorry, guys. Yeah, my machine is killing me. There's just one more thing we have to discuss, and then we can call it. But yeah, my machine is just not cooperating at the moment. What is working at 100%? It's OBS. Um, and Zoom. Games. Uh, Yash, is it laggy? Can you at least hear my audio? Is the video working, or is it like everything is really bad? Can you tell me, Yash, in DMs, is it workable? या फिर अभी हालत खराब है?
Audio would be fine, but the video and the screen is too laggy.
Screen is lagging. Alrighty. Cool. We'll do AMA until I fix this. Yeah, it is lagging a lot. I wonder why. If I closed everything now, other than Zoom, of course. If I do an edge stop, I don't see anything other than Zoom, and so I'll stop recording. Maybe that fixes it. Sorry, guys, just 1 second. Quit. All right, that stopped. Quit. Okay, there we go. I stopped recording. It worked. So it's 9:26. We might have to merge the Zoom recording from here. Cool, guys. I'm sure you guys can sort of see me now, hopefully. So what I was saying was we have pods, K-get pods, and we see none of them are working right now. We could start pods, K, Kubernetes, or whatever, sorry, kubectl, run whatever pod you want to run. The question is this the right way to run pods or is this not? And the answer is this is not. I still see a lot of lag. There, even though you can run, sorry, let me open the slides really quickly. Even though you can run Kubernetes like this, and the reason is because Kubernetes is what's called declarative. And, and whenever you want to start any resource, be it a pod, or eventually we'll understand other things like a deployment or a service or a bunch of other things, you should define them in a file, which is called the manifest file. So this is the last slide for today. Iske baad we will do a checkpoint then we'll do Q&A. The way we have started Nginx, which is doing this, is not the right way. It's good for testing. You can do it, but you shouldn't do it. Harkirat, then how do I start a Kubernetes pod? The answer is by creating what are called manifest files. What is this? This is what's called a manifest file, which is nothing but this described in the form of a YAML file. What does it say? The file says API version v1, which means कि ये जो kind है pod, when was this introduced in the Kubernetes API? So Kubernetes API becomes better and better over time, right? Initially, only pods were a thing, then services were added, then deployments were added, then a bunch of other things were added. So धीरे धीरे this matures. The API version V2, let's say, has more things. V3 has more things. So this represents कि pod कब introduce हुआ था, कौन से Kubernetes version में pods were introduced, and the answer is V1. The first version had pods as a construct. So API version V1. What are we starting? We're starting a pod. Metadata. So this is important. This will become very important eventually. But abhi ke liye, just a name for the pod. So whenever you write metadata name Nginx or metadata name Harkirat backend pod or metadata name Harkirat frontend pod, whatever you are writing, this becomes the name of your pod. So you should decide this. You should decide this very based on whatever the container does or the pod does. So abhi tak we were naming it Nginx or Mongo pod. The same thing you will put over here. So I'm hoping the first four are easy to digest. When was pods as a construct introduced? What are we starting? We're starting a pod. Metadata name Nginx, which means the name of our pod is Nginx. Then comes the next part, which is the specification. Spec. What all containers do I want to start? Spec containers, which is an array. We can start multiple containers inside the pod. We are just starting one right now, but we can add more blocks below it if we want to start Nginx and Mongo in the same pod. Abhi we don't want to. So that is why we have a single container defined over here. Name of my container, image that we need to pull from wherever, Docker Hub, and then the ports that we have open right now, which right now we only have the port 80 exposed. Again, this does nothing. Eventually, when we reach services, we'll understand how to expose applications. This is just more for documentation purposes. So let's copy this manifest file. Let's paste it, manifest.yaml. I've pasted this in a new file called manifest.yaml. Currently, I have one pod running. Let me stop it. K delete pod Mongo pod. As you can see, it's stuck in container creating, probably because my machine is really slow right now, so it's not able to start it. And again, it's probably not able to delete that either. K get pods. It's still terminating, right? The reason that is happening is because my machine is really slow right now, so it doesn't immediately delete. It doesn't immediately terminate either. Abhi bhi wo terminating mein stuck hai. But what am I going to do now? I have a file called manifest.yaml. I have. This looks wrong. We projects cohort 3 manifest.yaml. Let me copy this configuration from here. Let me paste it over here. And now, rather than doing k create pod whatever, nginx dash dash image equal to nginx dash dash port equal to 80, rather than doing this, I can just apply the manifest file. I know you guys see a lot of lag, but k apply dash f manifest.yaml. If I run this command, it does the same thing as running this command. Only I have a file where this is clearly defined. So I can keep updating this file, maybe push this file to GitHub, so on and so forth. That is the benefit of creating manifest file. And rule of thumb is always create files where you are writing all of this. Never run these raw naked commands directly. Always first create a file, apply the file. If you want to change something over here, that is fine. But never create raw commands like these or run raw commands like these. Always have a track of every file that you're creating, every resource that you're creating in your Kubernetes cluster. This does the same thing. If I do k get pods now, I see nginx pod is running. If I do a k delete pod nginx, then no pod is running. K apply dash f manifest. I reapplied the manifest. I restarted the whatever nginx container or pod. K get pods. It's container creating. Eventually it will run. Cool. So that is what a manifest file is. That is why you should use it. As I was showing you a few manifest files in Mobile Magic a while back, you saw they were all YAML files that I have written. And I hope it's obvious why they're a good idea, because you'll forget after 2 days what command you ran. If you ever want to update your cluster, update a specific resource, you won't have track of all the changes that you're making. If you go to github.com/code 100x/staging ops, you will see a bunch of these files that are changed every day. Maybe not every day, but quite often. So these are just similar YAML files. So if I open Algo Arena over here, you will see there's an application.yaml, a certificate.yaml, a frontend.yaml, a sealed structure.yaml, a sweeper.yaml. You don't see a pod.yaml here right now. You see a frontend.yaml, but it doesn't start kind pod. It doesn't have API version v1. It has API version apps/v1. It has kind deployment. It doesn't have kind pod for some reason. So what is a deployment is something we will discuss next week, or in an offline video we will see. But that's where we're heading next. Abhi tak, we have started a pod and we have started it using a manifest file. Good thing about a manifest file is you can keep track of them. And if I blame this, you will see I have all the commits where a bunch of these things were changed. So I have track of who changed what and how it was applied to my Kubernetes cluster. I can always roll back. I can, if I see there's a problem, I can go back a commit and reapply the manifest file. That's the good thing about this. And there's no bad thing about this. Cool. Okay. This is a good checkpoint. We understand clusters, nodes, images, containers, and pods. Before next week might be a great idea for you to learn deployments and replica sets yourself. And maybe services also. These three are also hard, but इसके बाद the real hard part begins when we have to understand certificates and ingress resources and ingress classes and CRD. बहुत कुछ. This is like the 101, which is good enough for deploying most applications. Like you'll work, most everything will work once you understand deployments, replica sets, and services, and maybe load balancer service. यहाँ तक great भाई. मतलब 101 Kubernetes done. You can deploy applications, good applications, scalable applications. इसके बाद is more internals. If you want to work at a not a full stack company that's doing DevOps, if you want to work at a real DevOps company, like a CVO basically, then the things that come after this become more important. But if you just want to work as a DevOps engineer in a full stack company, then if you know everything until load balancer and maybe ingress जो इसके बाद आएगा, then you are good to go. To recap, we understood what is Kubernetes, how we did things before Kubernetes, how we are doing things after Kubernetes. We created a Kubernetes cluster locally. We understood the Kubernetes API. We used kubectl to explore it. We tried to create a pod. We stopped the pod. We understood what was the manifest and how you apply manifest. Then I showed you a very big manifest that is currently running in production for a bunch of our projects. So every project that we have has a bunch of manifests that are all committed over here. There's also open source. Not that you learn anything from it, but you can see them, how they're being changed, what all do we have. If you want to explore them yourself, you should. Cool. ठीक है, class done. Let's do a poll. Other than the lag, do we understand everything? What is a pod? How do you create one? What is a manifest file? How do you apply it? If you understand this, the next week is deployment, replica sets and services, and load balancers. This will probably be next week. Then there'll be more like ingress and a bunch of other things. Cool, beautiful. This is great. That means if you understand this much, and 90% do, then hopefully next week we understand everything that was taught in Super 30 only, which was up until ingress. Which means then you can dive into more interesting concepts after that. Cool. So we'll do Q&A next. I'm going to open chat. The class is actually done. We're ending a little early because it's very hard. Maybe it's not. Like you guys are smart. Maybe I don't know. But yeah, at least in Super 30 or even like last cohort, I was seeing a lot of drop off here. 90% is good if you guys understand it. So firstly, any questions? Then we'll do Notion docs and everything. Any questions related to the class or otherwise? Cool. Yeah, my machine is going crazy right now. By we are applying a manifest file to start a pod. Do we need to create? Do we need to start a pod on a? Bhaiya, we are applying manifest file to start a pod. Correct. Do we need to start a pod on a particular node? We don't need to start a pod on a particular node. It can, the master node can decide that. If your question is, okay, how can I specify the specific node? So there's something called node affinity that you can use that does this. If you want a specific pod to run on a specific node, then there are ways to do it. But abhi the way we have done it, it will go randomly to whatever is the most relevant node right now. So in the local setup using kind, node is a Docker container inside which running pods which are running Docker. That is true. That is so true. Yes, that's tweetable, bro. Yep, that is true. So and that is why there are a bunch of challenges that we'll see next week if you're running Docker using kind. Please add offline videos of Kubernetes and any small topics that we can cover cohort fastly. I agree. I'm trying that, even though next month looks very busy, but I'm trying that. What was the dropout? What do you mean the dropout? I mean, the drop off. Generally, लोगों को समझ नहीं आता. What? Why the style of daily code? I mean, slides style different from slides going through. So there are two versions. You can change them. So switch to new UI, and if you want to switch to the old UI, select the three dots here and then click on switch to old UI. Most people prefer the old UI, even though the new one is fancy. All right, I'm opening chat again. My laptop is charging, so I'll just try to answer it here. Maybe put questions in on not Notion docs because it'll get a little hard for me to answer. Yet I only see Notion docs. So the process is still we haven't started yet. We just started mobile magic. Just make it work right now. I need to release a video where take you through the setup procedure. Once that happens, then just productionizing it would be nice. Talk about the different types of packages in Turbo. You had a common package front end and back end was getting errors regarding the same. Yes. So what you should do is you should have a separate backends common and front ends common and then common package. All the front ends, which is usually the UI package, is shared by the front ends. Backend common is common things that all the backends need, and then common is the things that work for both front end and backend, and that's how you avoid those errors. A kind request some to keep some paid scenes for 30 for the code. Yeah, that makes sense. But again, it will be very expensive if that happens. But we can do that. We can talk about different done. I have joined the course for a meetup. What do you mean? We had a meetup literally Tuesday on in Bangalore only. That was meant for it was initially exclusively open to the cohort only. That was probably the one where I was the closest to the student. You missed it. Tuesday only we did. We announced it on Discord. We announced it on YouTube as well. Hey Kirat, can you give it? Okay, answer that. I'm most probably won't be able to open Notion docs because I'm on the phone. I am Devansh currently in 8th semester. I know full stack learning fast API. I can code perfectly like crazy pixel perfect. If you can code pixel perfect and Python and fast API, then we can talk. There is a company that's hiring. Same company as Pulkit got into, but then got fired. But Joydeep has gotten into that company. They've hired another guy called Samrit recently for a lot of money. I don't know if they're hiring anymore, but they hired Samrit like 3 days ago. But if they are, at least give me a profile, especially if you know Python and fast API. I answered that same question again and again. Is Super 30 process done or still open? Just fill the form. We haven't yet started only. Infinite power. Can I okay answer that? An Nginx reverse proxy config. What happened to? I mean, just I'm not getting the time to look at it. But I want to productionize it before a video is coming with another comedian very soon for the Solana hackathon. So I want him to use it. So I want to productionize it before that. How much drop it? How much the comp was? He was expecting 50K and he's 19. There was a conflict because I told them 25K US. But apparently he makes a lot of money. He's really smart. Guess where he's from, guys? He's from Nepal. Sargamoli referred him to me basically. And so then there was a conflict. Then eventually I don't know, he has agreed at I think 30K or something like that. Features to add in mobile magic. Wait, productionizing it is the first one. I mean, look, intuitively think of a few features. One great one is you will see I have a React base image here, a React base prompt, next base whatever image, not image, but whatever boilerplate code, next ka prompt, and then I have a third one for React Native. Might be good to add like a 3JS starter or 3JS template, an Astro template, a Vue.js template, something like that, so that we can work with multiple frameworks. I think that's a great thing to add. More frameworks, and we can actually add Rust backends. We can add Node.js frontends. S3 backup is not done yet. So backing up to S3. Backing up to GitHub is also slightly done. Some people created PRs, but I didn't look into it too much. Then deploying it. Eventually, people might want to deploy it. We should host it. Things like these are good. Um, so and Super 30, if you want to get in honestly for free, this is probably the most high value thing you can do is contribute to anti-devs or whatever, mobile magic. Um, all right. How do I scroll to the bottom here? Too many questions. Stop pasting questions, guys. Or can you pause chat? I know Python Fast API. Currently working as a backend engineer in a startup. Cool. You should somehow get in touch. If you achieve this, what I will focus on. I think if you're at 9 already, and if you have 3 years of experience, aiming for 15, there isn't something specific you can learn. It's all about interviewing and probably just getting interviews for you. The biggest challenge is either getting that first offer or moving from whatever a 9 LPA to a 30 LPA remote offer, something like that. Then there are a few things specific that you can do. 9 to 15 is just interviewing wherever in Bangalore or somewhere else, finding that company that's hiring someone with a company who might. A lot of companies want 3 years of experience. 15 LPA is fairly humble for 3 years of experience. So just find those companies and do it. No degrees, 26. Give me some hope. It don't matter. Features to add in a fintech application. I mean, you have to elaborate more on what you mean by that. Like, what fintech application? What does it do? Uh, Cloudflare workers. Can you explain isolation architecture of Cloudflare? How they are and how they are different from Express or Next server. So Express is an HTTP server implementation. I'm assuming what you want to ask is if I start an Express HTTP server, or if I start a Next.js server, or if I start a Cloudflare, runtime server, what is the difference? So there are a lot of differences. First one being, okay, Express. The biggest question is, what is Express? It's just a wrapper on top of the native HTTP library that Node.js has. If you look at the source code of Express, you can actually read through it and you will see it's just 5 files, very simple files. They are all dependent on just routing added on top of the native HTTP library that Node.js provides. Cloudflare Workers is not that. Cloudflare Workers may, if you remember, we imported no HTTP library, not Express, not even something else. We did Hono, but Hono again isn't a HTTP library. It's a routing sort of framework. And then those routes are just given to someone to host. So someone else sort of starts it, which we don't know how they started. We don't know how Cloudflare starts the actual file that we give them, how they're serving files, how they're starting files. Some of it they've shared. And there are a few open source, few things that they've done open, a few projects that they've released open source that you can use to run, the workers locally. But yeah, the difference basically is, okay, when you're starting an Express server, you are using the native HTTP library. When you are creating a Next.js server, it's serving 10 different things, right? It's doing server-side rendering. It's doing a lot of things that the Express server doesn't need to do, or the, Cloudflare Worker server doesn't need to do. And then the Cloudflare Worker is, when deployed, just scaled along horizontally throughout in what are called isolates, and you don't have to worry about deploying. That's the high level difference. What is the difference between connection pooling and singleton? So they're very different things. Connection pooling is, okay, you have 20 machines that are all trying to connect to the same server. That is a problem. So you create a connection pool and you make those 20 different machines, different processes, talk to a connection pool, so that the DB doesn't get overwhelmed. Singletons are, okay, a single process that you have started. You started a single Node.js process, and Node.js project, Next.js project, but usme hi you created multiple database connections. To avoid a single Node.js process creating 20 database connections, you create a singleton so that the single Node.js process creates a single node database connection. So singleton as a concept makes sense for one process. Connection pooling makes sense if you're starting 20 different processes across different servers or the same server. Will connection pool not migrate the database, and if not, why? It will if you are using Neon. It will not if you are using Prisma Accelerate, because the Prisma Accelerate URL you already saw, right? It doesn't look like Postgres // something. It looks like Prisma // something. So it will if you are using a URL, a connection pool URL that starts with Postgres, which it follows the Postgres protocol. If it uses a special protocol, a new protocol, then it will not work. And then a tweet, and then this is my recent project, and I'm not opening the tweet, it'll just take me off the window. I am trying to build an Omega-like website. I'm using Go, WebSocket, Redis queues for front-end. What do I need to know? So only important thing you need to know is either Pyon or LiveKit. If you're using Go, you will have to use some WebRTC implementation in Go, which Pyon and LiveKit. Basically, Pyon is it. LiveKit is just a wrapper on top. So yeah, the library that you need to understand is Pyon. Everything else is straightforward. An HTTP framework, WebSocket framework, Redis client, so on and so forth. Cool. I should drop off, but because I have to meet someone at 10. Thank you all for joining. Sorry for the hiccup. I don't know what I did when I connected my laptop to my laptop. Good learning for me. I thought my I have to buy a new laptop. Seems like that's not the case anymore. Thank you for joining. I'll see you next week, where we will do. I'll try to see if we can do offline videos so we can complete deployment. I have a lot of offline videos. Let me just finish them. Next week we'll do deployment services and Ingress. Cool. We'll call it here. Have a good night. Bye bye.